fifth graders. We're going to learn about fractions. What are they really? A lot of us know not a lot of words to describe fractions. We might have been taught that the top number is called a numerator, the bottom number is called a denominator. We might kind of know how to make a model, but there might be some pieces that we aren't completely understanding about fractions yet, and that might be causing us to be confused as we move into harder and harder fraction problems, especially in fifth grade. So let's look at what fractions really are so that we can get all of our confusions out of the way and we can start doing amazing things in mathematics with fractions. So first, we need to remember always that fractions are ways in math that we represent parts and pieces, or parts or pieces, and wholes. So they're going to take a whole bar, make it into 4 pieces. If we count one of those pieces, we call it 1/4, 1 out of 4 pieces in the whole. We might have a model with a circle. Maybe it's a pizza or a pie in the real world. Maybe we cut it once straight down the middle and we take out and count one of those pieces. We call that 1 out of 2 pieces in the whole pie, 1/2. We can even have a group of things. This is a little different for a lot of people. We're used to seeing shapes cut into parts. We're not used to seeing a group of pieces put together. So here we have 3 stars and 1 circle. We have a group of 4 shapes. There it is. There's a group. I have 3 stars out of the 4 shapes all together in the whole group. That's another way to show a fraction. So let's back up and look at what are these parts of a fraction really talking about. When I see a fraction like this, 1 on the top and 4 on the bottom, I need to stop and slow down and think, what are each of these numbers representing in the real world? Just like we always think about math. So I like to start with the denominator, the number on the bottom. It represents each whole, having 4 pieces or parts in this problem. If it was a different number, it would be a different number of pieces or parts, but it always represents how many pieces or parts in each whole. Then we go to this top number, the numerator. It tells me how many pieces I am counting or how many parts. In this case, I am counting 1 piece or 1 part. If I make a model for this, I'm going to make 1 whole box. They didn't tell me what I was making holes of, so I'm just going to make it up. I'm going to make a box of candy since they didn't tell me. I have 1 whole box of candy, and from that bottom number, that denominator, I know that the whole box has to have 4 pieces of candy in it. Every box of candy for this problem has to have 4 pieces or 4 spaces in it for candy. Then I see my 4 spaces. I know that means that the denominator will be 4 because it's telling me that all of my boxes have 4 slots, 4 holes in them. Then I have to do my numerator, that top number, and it tells me that 1 piece is counted. So I just give it some stripes. I have 1 piece counted. We can see that came from that top number, that the numerator of the fraction. And so I would label my fraction 1 out of 4 pieces in the whole, 1/4. 1 piece was counted. There are 4 pieces in each whole box. I have 1/4, or the words 1/4 of a box of candy. Great. That probably makes a lot of sense to a lot of us. Most of us by 5th grade probably understand that part. But then we get fractions that look like this. 5/4. What? If I break it down, my top number tells me I have to count 5 pieces in this problem. And my bottom number, my denominator, tells me that each whole has 4 pieces in it. Now, if you're following along with me, you might be thinking, what? How can I count 5 pieces if a whole only has 4 pieces in it? That doesn't make any sense. Well, you're right, that is confusing, but there's a really simple way to solve that problem. So let's look at how we can use a model, and knowing what we know about what each of these pieces of a fraction represents, let's see what we can do. So here we go. We know that the 4 in the denominator means that each whole has 4 pieces. We know that the 5 in the numerator means we're going to be counting up 5 pieces. So let's just start making our model and see what happens. I'm going to make a model with 4 pieces in the whole set. Again, they didn't tell me what the whole is in this case, so I'm going to make a box with 4 pieces for candy in it. And now I'm going to start counting into those 4 pieces the candies that I'm supposed to count, which is 5 candies. So I've said 1, 2, 3, 4 candies. And because my whole only has 4 spots, I can only count 4 candies. But what now? I'm supposed to count 5 pieces of candy. My numerator, the top number of my fraction, tells me to count 5. What should I do? Well, let's just make another box. And I remember from my denominator that each whole has 4 pieces. So I put another whole, and it has to have 4 pieces. Now, I know that I have to count 5 pieces. I have 4 on the top model. I'm going to add 1 more down below. That makes 5 pieces. Now, I can count 5 pieces like my numerator told me to, and I still showed that each whole box has 4 pieces in it. All right, my model looks good. It matches the parts of my fraction. As long as I go step by step and I remember what each part of a fraction is telling me, I can make a model that shows exactly what's happening in my fraction. Now, I can look at this model as 5 pieces of candy, like I saw in my original fraction, with 4 pieces in every whole box. So I would have the fraction called 5/4. But I have a special situation here. I have 1 box of candy that's completely filled up with the purple striped candies. It's a full box. I can do something special when I'm counting fractions. I can group up that whole box and put a lid on it like that. It's 1 full box is ready to go. I'll just put a lid on it and call it 1 box. It doesn't have pieces anymore because I put the lid on it. If I opened the lid, I could see the pieces, but I put the lid on and called it 1 whole box. I can write that in math like that. Just a number 1. That represents 1 full box. Then I still have 1 extra candy down here out of the 4 holes in that whole box. So I would write that this way. 1 candy that I counted, 4 pieces in the whole box, and I would just stick that with my 1 from before, and that would look like that. I have 1 whole for the whole box. I have 1/4 for the extra box that didn't get filled up. It's the same amount of candy as 5/4. I just put a lid on the full box and called it 1, and just stuck the extra candy on the end of it, called it 1 1/4. I would write it this way, 1 1/4. Wow! Now that we know what the parts of a fraction are really representing, I bet you could write a model for any fraction you wanted to. Why don't you try it out and practice? Practice some fractions that have fewer counting pieces than they have pieces in the whole. So a smaller number on the top in the numerator and a larger number on the bottom in the denominator. Try drawing a box of candy pieces that has the number in the denominator shown and the number in the numerator striped. Then challenge yourself and try representing some fractions that have more counting pieces, a larger number in the numerator, and a smaller number of pieces in each whole, a smaller number on the bottom in the denominator. See if you can make a model for any fraction at all. If you can, you're well on your way to being able to do anything with fractions. Add, subtract, multiply, divide. As long as you understand what the parts of a fraction mean, you have the foundation for any of those things. Have fun exploring with fractions, mathematicians. I will see you in our next video.